Hi everyone, and welcome to The Sleepy Scientist. I'm really happy you're here. Tonight, we're going to go on a calm and quiet trip to learn something amazing. So get comfy, take a deep breath, and let's enjoy this peaceful science story together. Before we start, tell me in the comments, where are you watching from and what time is it for you right now? If you like relaxing science videos, don't forget to tap the like button. Now let's begin.
Deep beneath the weight of forests and cities, beneath deserts where no footsteps echo and mountains where no sound lingers, something ancient flows, silent rivers, hidden from the world above. These are not rivers as we know them, not sparkling with light or teeming with fish, but slow-moving threads of water locked in stone. Beneath the earth's crust, water seeps and slumbers, winding through fractures in bedrock, collecting in forgotten hollows where no eyes have looked. Some of these waters are older than rain, older than rivers, older even than the trees. They fell to the earth in another time, before the continents knew their names, before the sky knew the song of birds. Trapped in aquifers miles beneath our feet, these waters move not in hours or days but in centuries. Imagine a river that does not rush but listens, a stream that does not sparkle but remembers. Each droplet carries whispers of what it once touched: volcanic ash, ancient pollen, the dissolved bones of vanished creatures. Geologists call them fossil waters. Some were sealed away more than 1 million years ago, and still they flow, drop by drop, like a clock that forgets to tick. The crust of the earth is not solid, not truly. It is broken, veined, and folded like an ancient parchment. Water finds these pages, curling itself through the cracks, softening rock, etching tunnels in silence. In these hidden places, it meets the minerals of Earth's deep heart, iron and calcium, silica and sulfur, and dances with them slowly, shaping them grain by grain. Over time, the water becomes something else, infused with the memory of stone, heavy with secrets. There are caverns so deep, sunlight is only a myth, and yet even here the stone drinks. Through porous rocks and narrow veins, water travels in invisible trails. No sound accompanies its journey, only the sigh of pressure, the slow exhale of heat, and the patient embrace of the planet. The deeper it goes, the more it changes. Pressed by the weight of miles above, warmed by the breath of magma below, it becomes a different water, rich, mineralized, and ancient. Somewhere beneath the Canadian Shield, one of the oldest regions of exposed rock on Earth, scientists found water trapped for more than 2 billion years. When they opened the rock and let the water free, it bubbled as though alive, releasing gases that hadn't touched air since before multicellular life existed. It was a meeting across time, human hands touching the breath of an Earth no longer here. And that water, clear and humming with mystery, told them stories through its chemistry. Tales of vanished seas, sunless ecosystems, and heat that never rises to the surface. Not all water beneath the crust lies still. In some places, it moves not fast but persistently downwards, sideways, in loops shaped by gravity and heat. Hydrothermal systems pulse near the edges of tectonic plates, where the planet itself is opening. Here, ocean water slips through cracks in the seabed, is heated by magma, and rises again through vents like breath escaping a sleeping mouth. These deep-sea geysers, known as black smokers and white smokers, release clouds of minerals into the abyss. Around them, in the complete absence of sunlight, life blooms. Imagine that, rivers beneath stone giving birth to life in darkness. Whole ecosystems exist around these vents, filled with creatures that have never seen the sky. Giant tube worms with no mouths, blind shrimp that feel instead of see, and bacteria that feast on sulfur rather than sunlight. These beings are sustained not by the sun, but by the warmth of the Earth's core and the silent rivers that carry its heat upward. And further still, beneath the crust in the deep biosphere, microbial life lives within the rock itself. These tiny organisms survive on what the river leaves behind: hydrogen, methane, trace metals, thriving in pores and fissures, in darkness more perfect than any night. They live slowly, some dividing only once every 1,000 years. But they live. And that, perhaps, is the quiet miracle of these underground waters. They carry not only memory but life. When we look at a river, we see motion and music. But beneath the crust, water has a different voice, one of stillness, of endurance, of hidden currents shaping the bones of the earth. These are the sleeping rivers, wrapped in stone like dreams yet to be spoken. They do not rush. They wait. They teach us that not all rivers must be seen to be real, that water can flow without a sound, that the earth carries within it a patience so profound it makes our own seem like wind in passing. So next time you stand on the ground and feel nothing beneath your feet, remember, far below, water moves, softly, deeply, faithfully. It carries secrets not meant for surface minds but for those who listen slowly. It flows not to be seen but to be understood. And maybe, in its own silent way, it is waiting to teach us something about time, about pressure, and about the beauty of what endures unseen. Beneath the surface where roots surrender and bedrock begins, the water that hides is not forgotten, it is becoming. Every inch it moves below is shaped by time's invisible hand. Through sediment and shale, past chambers shaped by ancient eruptions, the water threads itself like a soft needle sewing the planet's memory. It traces the outlines of long-collapsed caverns and folds itself around the broken backs of fallen tectonic dreams. This is not the rush of springtime rivers or the crashing of waves. This is the slow, meditative drift of persistence, written in silence and pressure. These underground waters are libraries of minerals. Calcium drifts into them from limestone's surrender. Iron bleeds slowly from crumbling veins of ore. Silica, boron, magnesium, they all dissolve into the flow, like letters falling into ink. As water moves through these stony corridors, it becomes an alchemist. The minerals it gathers form crystals in deep vaults where no torchlight ever flickers. Some grow into delicate blades like frozen moonlight. Others branch like trees, as if Earth herself had sculpted forests in the dark. Each crystal is a quiet monument to patience, a shape that time dreamed of and stone delivered. And while we picture the planet's interior as a place of crushing silence, it is alive with motion. Earthquakes begin far below as the slow tension of shifting plates finally slips. That shudder, when it comes, sends waves across the underground rivers, distorting their course, splitting aquifers, even creating new paths. But the water does not panic. It adjusts, always finding the next opening, the next downward slope. It does not resist change, it follows it. In that it offers a lesson too subtle for most to see. When shaken, flow rather than break. The temperature rises the deeper the water travels. The crust holds pockets of warmth like a sleeping creature holding breath. When the water reaches these thermal veins, it does not boil. It transforms. It extracts even more from the rocks it touches, pulling heat, salts, and rare gases into itself. These enriched waters can carry gold, silver, even uranium, not in chunks, but dissolved, invisible. In mountain ranges long vanished beneath the sea, these waters once carried enough gold to seed entire veins that miners would later chase with torchlight and chisels. What is buried is not always still. Sometimes water in these unseen places becomes pressurized until it explodes upward, splitting rock and releasing its burden like a story too long untold. These bursts carve new chambers, expand fissures, create the voids where gems may grow. In this way, the water is both sculptor and scribe. It builds the hollows and then fills them with brightness. And beyond the physical, there is the biological life that has no need for the sky. Microbes in the deep biosphere feed on minerals dissolved in these waters. Their metabolisms, so different from ours, are tailored for scarcity. They do not bloom, they endure. They exist in tiny pockets, sometimes just a few cells per teaspoon of water, living at the edge of chemistry. Some of these microbes consume hydrogen released by the decay of radioactive elements deep in the crust, a form of life powered not by warmth or light, but by the quiet hum of atomic unraveling. This water is not waiting to be discovered. It is not calling to us. It is simply asterisk being asterisk. Its journey is inward, not upward. It does not crave escape. The flow of subterranean rivers is not toward the ocean, but toward equilibrium. They seek balance in temperature, in mineral content, in pressure. Every drop is engaged in this act of evening out, smoothing the extremes of Earth's interior, calming the turbulence beneath our knowing. In karst landscapes where limestone beds have been hollowed by dissolving waters, underground rivers become more dramatic. They tunnel entire systems of caves, some vast enough to hold cathedrals. Here, water has teeth. It carves domes, arches, and flowstone sculptures. It hums against the stone, shaping smooth walls that echo like memory. In these spaces where bats sleep and silence rings, the water tells stories in drip and rhythm. But even here, beneath all that artistry, it keeps moving downward, further still into deeper stillness. Across continents, these hidden waters connect. They form vast aquifers that span thousands of miles. The Great Artesian Basin beneath Australia, the Ogallala Aquifer under the central United States, both carry the legacy of ancient rainfall, stored in sandstones beneath deserts and plains. They are time's reservoirs, holding the breath of climates long vanished. And when we draw from them, we are not just taking water, we are drawing from the past. Imagine rain falling during the Ice Age, slipping between grains of glacial soil, drifting downward for thousands of years, never evaporating, never returning to the sky. Now imagine that water reaching your faucet, carrying within it the cold memory of mammoths and frozen winds. This is not a metaphor. It is real. Groundwater can be this old, this preserved, this quietly magnificent. Beneath the crust, water is never alone. It travels with heat, with gases, with whispers of life. It records every passage, every change in rock, every shift in pressure. It is a silent companion to Earth's transformations, from the rise of mountains to their slow collapse, from the drift of continents to the tremble of fault lines. In every event the surface remembers, the water has already been. And though it is invisible to most of us, though it is locked away where no eye can follow, its presence shapes the world above. It cushions faults, nourishes deep-rooted forests, even affects gravity in subtle ways. When aquifers are drained, the land can sink quietly and irreversibly. When pressure builds in a water-filled cavity near a fault, an earthquake may follow. The water beneath our feet is not passive. It is a player in the planet's rhythms, slow, deep, essential. The rivers beneath stone do not ask to be known. They are content to move without map, to shape without hand, to exist without name. But in knowing they are there, we feel something shift, a quiet sense of belonging to a planet still full of secrets. The surface may be ours to cross, but the depths are still its own. And the water, slow, soft, and eternal, is the keeper of that secret heart. Beneath the crust's layered hush, where sunlight cannot reach and time holds no clock, the story of underground water arrives at its final turning. Here, it no longer seeks passage but becomes part of the stone, absorbed into the framework of Earth itself. In pockets sealed by tectonic folds, in caverns wrapped in silence, water finds rest, not as stillness, but as union. It merges with minerals in crystalline marriages, filling voids with opal light or fossilizing ancient shells that no eye will see. It loses its form, but not its memory. In these depths, where pressure warps molecules and temperature nudges chemistry into new shapes, water is more than a liquid. It is a medium of change. It ferries elements into positions they would never reach alone, enabling the growth of rare gems, the creation of ore bodies, and the restructuring of rocks into new identities. It is an artist with no brush, a sculptor whose hands are unseen. It works in epochs, not hours, crafting beauty in hidden rooms no foot will tread. Even in the deepest fractures of the crust, life sometimes appears. In sulfurous pools sealed from the surface for tens of millions of years, microbial colonies glow faintly with biochemical life. These organisms feed not on sunlight or oxygen but on the slow decay of rock, drawing energy from minerals most creatures would find barren. In these unseen ecosystems, water is the great enabler. It transports nutrients, dissolves waste, and offers just enough mobility for life to anchor itself in the impossible. Far below volcanoes, where magma swells and shifts in molten tides, supercritical water exists in a state unlike anything at the surface. It is neither vapor nor liquid but both, so hot, so pressurized, that it can dissolve rock itself. This supercritical water moves through volcanic systems, picking up elements like copper and lithium, creating the mineral veins upon which entire industries will one day depend. Yet as it rises, it cools and changes again, dropping its load, condensing back into something more familiar. A cycle ends, a resource is born. In zones where continents collide and mountains are raised inch by inch, water within the crust becomes a silent negotiator. It lubricates faults, making earthquakes more likely but sometimes less violent. It reduces the strength of rocks under pressure, allowing them to fold rather than fracture. Without this presence, the crust would be more brittle, its shifts more violent, its scars more final. In this way, water deep within the earth is not only a geologic actor, it is a peacemaker between forces too massive to imagine. When we study core samples drilled from miles below, the water within them tells us more than just composition. Isotopes whisper of ancient climates. Ratios of gases hint at vanished atmospheres. The way molecules are arranged reveals the temperatures they endured. This fluid is not simply moisture. It is a record, etched in atoms, of Earth's invisible past. To hold a vial of ancient groundwater is to hold a chapter of planetary autobiography written without ink. Yet even with all this knowledge, so much remains beyond our grasp. We do not know the full extent of deep water's pathways. We cannot chart every aquifer, every fissure, every pocket where the planet's secrets sleep. We can only listen to the vibration of tremors, the chemical signature of springs, the rare gas exhaled from a borehole. We are the students of a teacher who speaks without words, and the lesson is always unfolding. At times, water beneath the crust breaks free. Geysers erupt. Springs emerge in unexpected valleys. Mineral waters bubble up from unknown depths. These are moments when the underground speaks, not in fury but in invitation, offering us a glimpse, a taste, a scent of what stirs below. It's as if the earth exhales, and in that breath we feel its heartbeat. In Iceland and New Zealand, in the high Andes, we find places where the veil is thin, where warmth seeps through the ground and water speaks with steam. In these geothermal regions, the deep crust reaches upward through water's voice. Pools shimmer with strange colors and the air hums with energy. These are not merely natural wonders, they are conversations. If we listen closely, we may begin to understand what the planet tries to say. But most of what lives beneath the crust will never surface. The rivers that thread through granite and slate, the pockets of ancient seawater sealed by uplifted seabeds, the aquifers beneath salt flats and tundras, they will remain where they are, cradled by silence. Their stories are not unfinished, merely unread. And perhaps that is the final beauty of these waters. They do not exist for us. They have flowed without audience for millennia, shaped continents without applause, sustained life no eye has seen. Their purpose is not performance but persistence. They remind us that not all wonder is visible, not all movement is fast, not all life needs light. So when you lie awake and feel the world spinning quietly beneath you, remember the rivers that dream in stone. They are not in a hurry. They do not seek the sky. They carry the memory of Earth in every molecule, and in their stillness, they teach us how to endure, how to change, how to be part of something vast and unseen. The sleeping rivers beneath stone continue their journey, patient, unspoken, complete. Far below the crust's quiet firmness, where no tree can root and no breeze can stir the dust, there is a realm of waiting fire. This is not the fire of candles or of sunlit heat, but a dense, molten silence held in place by the weight of the world. Magma sleeps in chambers hollowed by pressure, not stirred by light but by gravity and heat. It is the blood of the planet, thick with elements forged in stars, yet it flows beneath our feet in total darkness, gathering strength in slowness. Beneath mountain roots and seafloor ridges, magma swells like a hidden breath. It does not rush upward, nor does it seek release without cause. It lingers in the deep crust and upper mantle, cushioned by the very rocks that fear its arrival. Though it moves with the possibility of eruption, it spends most of its life waiting. And in that stillness, chemistry unfolds like a quiet symphony. Silica gathers and separates. Gases dissolve. Minerals arrange themselves into molten configurations only the earth remembers how to shape. The mantle, deeper than any mine has reached, flows in slow convection. Heat rises from the core, folding solid rock into drifting currents. In these currents, magma is born, not in explosions but in gradual transformation. Temperature melts peridotite, the heavy rock of the upper mantle, into pools of semi-liquid fire. From these pools, buoyant plumes rise in silence, stretching upward through layers of denser rock. Sometimes they cool before surfacing, forming vast basalt layers buried beneath younger stone. Other times, they collect beneath the crust like thoughts unspoken, building toward eventual expression. In subduction zones, where one tectonic plate slides beneath another, water trapped in sinking rock is released into the mantle above. This sudden moisture lowers the melting point of surrounding rock, creating new magma that rises with ease. It travels through faults and fissures, threading upward through weaknesses carved by ancient quakes. But even then, it may never surface. Much of Earth's magma lives and dies beneath, forming intrusive bodies like batholiths and laccoliths, locked forever in subterranean architecture. Volcanoes are merely the rare mouths of this deep furnace. Most magma never erupts, never spills into the sky. Instead, it cools underground, forming the roots of mountains we cannot see. Granite, that common face of ancient landscapes, is the fossilized memory of forgotten magma. It tells us that fire once rested here, deep and slow, hardening over millennia into crystal frameworks now exposed by time. Magma does not roar in its early life. It simmers, it thickens. It accepts minerals from its surroundings, changing its composition and potential. Some magmas become rich in silica, forming rhyolite when cooled. Others are iron-heavy, destined to become basalt. This quiet variance determines the nature of future eruptions, whether a volcano will flow like honey or explode like thunder. Yet even these futures are undecided, for many magmas never find release. They crystallize within unseen, their story unfinished but not untold. And while we picture magma as chaos, it is more often a methodical, heat-driven dance of molecular drift. It gathers slowly, reshapes patiently, expands gently. Every movement below shifts the balance above. Uplifted domes and cracked fault lines bear witness to these underground preparations. Even the tilt of a landscape can hint at what stirs beneath. The earth speaks softly before it acts. There are places like Yellowstone where magma pools near the surface. Their geysers breathe in rhythm with subterranean heat, and the land pulses with warm breath. Scientists monitor ground deformation, gas emissions, and seismic murmurs, trying to decipher the magma's intention. But magma, like thought, does not always become action. It may rise close, then pause. It may shift sideways, then fade. Its timeline is not ours. In oceanic ridges, magma rises almost constantly, creating new crust in a gentle rhythm that builds the seafloor over eons. These mid-ocean ridges are the planet's open veins, quietly bleeding heat into the cold dark. Here, magma touches seawater and solidifies in pillow-like forms, expanding the Earth's skin one breath at a time, without fanfare, without panic. And sometimes, magma's influence is invisible, expressed only in the heat it shares. Geothermal energy, drawn from Earth's interior, powers homes and warms waters in places like Iceland and Kenya. That warmth is not a gift of flame, but of deep, steady burning that never seeks an audience. It reminds us that fire can exist without destruction. In the beginning, the Earth itself was molten. Its early surface shimmered with liquid rock, unstable and hot. Over billions of years, the crust cooled and thickened, but magma remained beneath, less visible, no less essential. It is a memory of Earth's youth held in present form, a reminder that the planet, though it walks quietly now, was born in fire and still carries flame beneath its skin. To know magma is to understand stillness that holds potential. It is not fury, it is readiness. It waits not for permission but for balance. When that balance tips, it rises. When the moment is wrong, it rests. Its patience is geological, its voice low and persistent. It does not need to speak loudly to shape mountains. It needs only time. Beneath layers of basalt and granite, magma exists not as a storm but as a constant breath in the Earth's chest. It does not surge unless compelled. It thickens in chambers that change shape with every pulse of heat. In those unseen hollows, gases accumulate: carbon dioxide, sulfur dioxide, water vapor, rising from molten depths like thoughts gathering behind a closed mouth. These gases do not escape at once. They press, dissolve, recombine, forming invisible signatures that hint at what simmers far below. Each magma body is unique. Its temperature, mineral content, and depth determine its behavior. Some are dense and slow-moving, rich in iron and magnesium, pushing forward like syrup through a maze of solid stone. Others are lighter, infused with silica, more prone to internal pressure and sudden ascent. But even then, the journey upward is uncertain. Magma may stall, absorbed into the crust, freezing into stone veins that weave through older rock like messages never delivered. Only a few ever find a path to the surface. And still, the land feels them. Ground swells in places long thought stable. Earthquakes ripple across regions where no wind blows. These are not warnings but conversations, small exchanges between Earth's outer stillness and its inner fire. Instruments record the rise of magma not through sound or color, but through motion too subtle for the body to feel. The planet shifts by millimeters, and yet those slight tilts reveal a churning world just out of reach. Magma also teaches us about transformation without noise. It alters surrounding rock through contact, heating it until new minerals form: garnet, biotite, hornblende, born not of sediment or time but of sudden warmth. These rocks, altered by intrusion, mark the quiet footprint of fire. No explosion announces them. They simply appear, changed forever by a touch they could not resist. Deep beneath the Andes, rising magma creates massive domes of granite and rhyolite, never erupting but pressing upward year after year. These intrusions shape the land, lifting mountains inch by inch, carving new valleys not by force but by endurance. In these instances, magma is not a destroyer but a shaper of silence, modeling landscapes with pressure, not flame. As magma crystallizes, the remaining melt becomes increasingly concentrated in rare elements. Lithium, used in modern batteries, is one such gift from deep geologic distillation. In cooling chambers deep underground, magma leaves behind pockets rich with resources: fluorine, boron, molybdenum. materials essential to life as we know it today. These hidden caches are not leftovers. They are the end result of a long, precise evolution guided by heat and time. Sometimes magma meets water. When it does, the result is both violent and beautiful. Steam forms instantly, expanding with force, breaking rock, hurling ash. These phreatomagmatic eruptions create Mars, broad, low craters filled with calm water long after the fury fades. Yet these dramatic moments are brief. Most of the time, magma and water live parallel lives, influencing each other only through heat gradients and mineral exchange. In ancient greenstone belts, remnants of Earth's earliest crust, we find evidence of submarine volcanic activity from billions of years ago. Pillow lavas, formed as magma cooled underwater, preserve the texture of a time when life had barely begun. These frozen shapes, now embedded in mountains, remind us that magma once touched the first oceans, changing the chemistry of the seas and perhaps laying the foundation for biology itself. Even today, beneath mid-ocean ridges, magma rises continually, forming new crust in rhythmic pulses. It does not explode but spills, thin sheets that cool within moments of contact with water. This process, invisible to human eyes, adds miles to the ocean floor every year. A quiet construction project stretching thousands of miles, powered by the ceaseless breath of the mantle. Hydrothermal vents near these ridges host some of the planet's most remarkable life forms. Here, magma heats seawater filtered through crustal rock, infusing it with metals and gases. When that water escapes, it forms towers of minerals, chimneys that release warmth into the deep ocean. Around them, creatures flourish without sunlight. Tube worms, clams, and microbial mats depend entirely on heat and chemical richness born of magma's quiet labor. The gases released by magma can travel upward through tiny cracks, reaching the surface long before any eruption occurs. These emissions tell stories in composition. Sulfur hints at depth, helium ratios suggest mantle origins, carbon dioxide forecasts possible movement. Scientists monitor these signs carefully, listening to the Earth's breath for changes in rhythm. But like dreams, not all hints become events. Many fade, absorbed by wind and rain, forgotten by the surface even as they continue below. Some magma never cools. It flows slowly through the mantle, rising and falling in cycles that last millions of years. These mantle plumes, rooted near the core, create hotspots that break through the crust wherever they meet it. The Hawaiian Islands are the surface expression of one such journey, a trail of cooled lava marking the path of magma through time. But the plume continues beneath, indifferent to oceans or nations, its story measured in continents. To stand on cooled lava is to stand on the skin of magma's long path. Every crack, every ripple, every air bubble trapped inside the stone tells of temperature, motion, and release. These rocks remember the viscosity of fire. They bear witness to the planet's breath solidified mid-sigh. And we, walking above them, are closer to Earth's inner fire than we know. What magma does beneath the crust is not confined to geology. Its heat shapes weather patterns through volcanic eruptions. Its movements alter magnetic fields through shifting minerals. Its eruptions release particles that influence global climate. Yet none of this is its purpose. Magma exists because Earth is not static. It is a continuation of planetary formation, a function of internal energy still unwinding from the birth of a world. The fire beneath is not restless, it is purposeful. It does not burn with anger or haste, but with design. Magma does not seek destruction, it enables transformation. It turns solid into liquid, then back again, rearranging the architecture of continents, lifting the floor of oceans, feeding ecosystems where no light shines. It is the Earth's slow exhale, its deep whisper of movement and becoming. There is a point beneath the crust where magma no longer rises but settles into place. It thickens with age, cools in layers, and becomes a memory locked in stone. As it crystallizes, its heat bleeds outward, warming the surrounding rock until it too begins to change. This slow diffusion, cell by cell through the lattice of minerals, writes a silent message into the heart of the earth. No burst of light, no tremor, only transformation by proximity. When magma comes to rest within the crust, it forms structures that redefine the world above. Sills, dikes, laccoliths. These solidified remnants spread like roots beneath mountains, lifting landscapes without surface disruption. Their shapes reflect ancient directions of pressure, frozen movements that once carried potential upward. Yet once solidified, these features remain in place for millions of years, shaping topography through silent insistence. Each intrusion creates a new chemical environment. As the magma cools, different minerals emerge at different temperatures. Olivine may form first, followed by pyroxene, amphibole, and eventually feldspar and quartz. This process, called fractional crystallization, is not quick. It can take centuries, even millennia, for one body of magma to fully solidify. Yet during that time, the melt evolves, becoming more refined, more concentrated in rare elements, more poised to nourish the crust with valuable materials. In remote mountain ranges, granite domes stand as the polished result of this quiet labor. Their massive forms once lay hidden, buried beneath layers of ash and sediment. Over eons, erosion swept those coverings away, revealing the fossilized heart of ancient magmas. These smooth bulks of stone rise above the tree line, unmoving, yet alive with the memory of heat. The fire no longer burns within them, but their shape, their mineral threads, their sheer endurance whisper of a story carved in temperature. Elsewhere where magma once met the surface in explosive union, volcanic cones now slumber beneath moss and mist. What was once fury is now forest. Basaltic flows, long cooled, crack in geometric harmony, columnar joints shaped by contraction as heat fled the stone. These pillars, sharp-edged and rhythmic, speak not of chaos but of order written in cooling silence. Their pattern is not accidental. It is the language of structure, translated by fire. The gases released during the final phase of magma's journey rise into the atmosphere, influencing rain patterns and feeding clouds. Volcanic aerosols, fine particles of sulfur and ash, can cool the planet, reflecting sunlight for months or even years. The effects are not confined to the site of eruption. A distant mountain's breath can shift global temperatures, dimming skis halfway across the world. In this, magma reaches further than its heat alone could stretch. Even when magma remains below, never erupting, it leaves behind thermal fingerprints. These gradients warm groundwater, turn springs into spas, and power geothermal systems. Towns tap into this legacy, drawing warmth from stone that once flowed. The energy is clean, quiet, and ancient, drawn from processes that began long before any human name was spoken. In some places, the remnants of ancient magma feed life in unexpected ways. Soils formed on volcanic rocks are among the most fertile on Earth. The minerals released during weathering nourish crops, forests, and grasslands. Indonesia's rice terraces, Italy's vineyards, the Hawaiian taro patches, all thrive because of what magma left behind. Fire, transformed into sustenance. And in the deepest chambers of the earth, where pressure refuses to lessen and the rock remains pliable, magma continues to move. Not toward eruption, but as part of a vast conveyor beneath the crust. Mantle convection cycles magma down at one end of a tectonic plate and up at another. This cycle never rests. It underpins continental drift, creates ocean basins, lifts ranges skyward. Without it, the planet would be still, lifeless, cold at heart. Scientists peer into this inner world with seismic tools and magnetic readings. They measure tiny variations in gravity, trace anomalies in density, and chart echoes of waves moving through different materials. Magma reveals itself not directly, but by how it changes the paths of other forces. Like a whisper that alters a room's stillness, it cannot be seen, but its presence is felt in every deviation, every delay, every unaccounted curve in the signal. Yet for all our tools, much remains hidden. The earth guards its molten heart with stone and silence. We send probes, build models, simulate flows, but we do not touch magma until it touches us, rising in sudden bursts or cooling in centuries of forgotten depth. Our knowledge, vast as it may seem, is only a thread in the fabric of its history. There is a humility in knowing that the land we walk on rests atop a restless core, that mountains we admire began not with thrusts from above but with stirrings from below, that the continents themselves drift, pulled by forces shaped in magma's heat. The ground beneath our feet is not anchored. It floats on currents older than language. Magma's story is not a tale of destruction. It is one of renewal. It breaks to build. It burns to restore. It reshapes the earth not in moments but in lifetimes beyond counting. Its patience is its power. Its silence its strength. So the next time the world above is still, the trees quiet, the air calm, the soil unmoving, remember what waits below. Magma, the silent architect, the deep composer of landscapes, continues its unseen work, not to be feared but understood, not to be conquered but respected. Its whisper rises through the bones of the planet, and in listening closely, we begin to hear the slow heartbeat of the earth. Beneath the surface, where light cannot reach and time moves at a pace known only to stone, a quiet transformation occurs. Here, in the depths of Earth's crust, crystals grow not from the touch of light, but from the steady pressure of the world above. In this hidden realm, minerals shift and reform, unseen and untouched, as they wait to take on the shape they were always meant to possess. Their growth is not a rush, but a slow unfolding, a quiet expansion that whispers of patience and depth. It begins with atoms, small, persistent, and ever searching for a place to settle. In the warmth of the Earth's inner layers, they gather in secretive corners, bound by the pressure of thousands of miles of stone. As these atoms align, they form bonds, creating structures that will one day become the shimmering crystals that catch the eye. These crystals do not rise in haste, nor are they shaped by the passing winds. They form instead in the silence of the Earth's deep heart, where heat and pressure pull them into being. Take, for instance, the growth of quartz. This common crystal, often clear or slightly tinted, forms in the cracks and voids of the Earth's crust. Over time, as mineral-rich water seeps through rock, silicon dioxide, an element found in abundance, slowly crystallizes along the edges of fractures. What begins as a faint trace of mineral deposits over generations becomes the beautiful, clear faces of quartz. The growth process is so slow that a single crystal can take millions of years to form. The very structure of the crystal, its symmetrical faces and delicate edges, is a testament to the unhurried nature of Earth's deep processes. Yet not all crystals take the same path. Some, like the towering columns of selenite, grow in layers, as each new layer of mineral-rich solution is deposited in a controlled, patient fashion. These crystals often stretch over long periods, sometimes growing into immense lengths as they slowly reach toward the Earth's surface. Their formations are quiet echoes of time itself. Each layer added is another moment in the long history of the Earth's inner workings, a silent witness to the years that pass above. Further still, in the depths where magma once flowed and cooled, other crystals take shape in the cooling veins of igneous rock. Tourmaline, garnet, and other precious stones are formed from the minerals trapped in these molten flows, their colors and shapes determined by the precise conditions of pressure and temperature. These stones are born in the dark, formed from minerals that were once part of molten fire. The crystals that grow in these depths are not the soft jewels we often associate with beauty, but the rough, sharp-edged markers of the Earth's violent and powerful past. In the deepest pockets of the Earth's mantle, where pressure reaches unimaginable heights, crystals take on even more extraordinary forms. The diamonds that are so highly prized above ground are born under these extreme conditions. They are created not through simple growth, but through a process of compression and transformation. Carbon atoms, once part of softer minerals, are pressed under thousands of times the pressure of the Earth's surface until they bond in a structure that is as hard as any substance known to man. These diamonds, born in the furnace of the Earth's core, are not visible to the eye until they are drawn to the surface by the eruption of volcanic forces. What is remarkable about the process of crystal formation is not just the materials involved, but the time it takes for these structures to emerge. Some crystals, like those that form in caves, grow in the steady drip of mineral-laden water, taking thousands of years to reach their final, gleaming form. Stalactites and stalagmites, created in limestone caves, are shaped drop by drop. The journey from mineral-rich water to the crystal formations we see in caves is a slow dance, a gradual accumulation of minerals in the cold, silent darkness of the Earth. This formation is not just a random occurrence. It is a calculated process that happens in specific conditions, whether under the influence of heat, pressure, or the slow movement of water. Every crystal's shape, color, and size are determined by the conditions around it. The surrounding environment, whether in a deep, dark cavern or in the space within a mountain's heart, determines how the crystal grows. And in this way, the Earth's crust acts like a slow-motion artist, shaping these natural sculptures over time. Though crystals grow slowly, their creation is not without disruption. Occasionally, earthquakes, volcanic eruptions, or even the gradual shifting of the Earth's plates can alter the trajectory of a crystal's development. These sudden shifts can fracture crystals, change their shape, or even interrupt the growth process entirely. Yet, even in these moments of turmoil, the deep forces that shape crystals continue their work. The pressure of the Earth, the heat of the mantle, and the flow of minerals do not stop. The Earth's deep interior is a place where even disruption is part of the process. And so, deep beneath the crust, where the human eye cannot see and the ear cannot hear, crystals grow in secret. They are formed not by the whims of nature, but by the patient forces of pressure, time, and heat. They take on their shapes with deliberation, changing the landscape of the Earth one molecule at a time. Each crystal, formed from the building blocks of the planet itself, is a small monument to time's patient march, a living testament to the Earth's power to create beauty from darkness and pressure. The formation of crystals beneath the Earth's crust is a slow, steady process, yet it is one of the most profound expressions of the planet's inner workings. As magma cools and minerals dissolve into subterranean water, new crystals begin to form in the deep. These formations do not emerge as perfect shapes overnight but grow in careful stages. Each phase of their growth is marked by tiny changes that add up over time, leading to the intricate, shimmering structures that eventually make their way to the surface, often in the most unexpected ways. The minerals involved in crystal growth are not always abundant. Sometimes, they are rare and hidden deep within the Earth's layers. As molten rock cools, it crystallizes slowly, and the minerals that once existed in liquid form solidify into organized patterns. The elements in the magma become part of the crystals, forging their bonds in the warmth of the Earth's interior. These bonds are not just chemical, they are stories of the forces that shaped the planet millions of years ago. The arrangement of atoms in a crystal reflects the conditions of the Earth at the time of its formation, revealing a history that stretches far beyond what the eye can see. The geologic environment plays a major role in determining the size, shape, and color of the crystals that form deep beneath the surface. The deeper the crystals grow, the more intense the conditions. The heat increases, the pressure builds, and the minerals respond by changing, adapting to their environment. A simple crystal of salt may form under mild conditions, while a diamond, a symbol of rare perfection, forms only when extreme pressure and heat work together over billions of years. These conditions are not merely elements of chaos, but are carefully orchestrated by nature's hand, which guides the mineral growth in an ordered, systematic way. As crystals grow within the earth, they remain untouched by time above the surface. Only those with the patience to dig deep, to penetrate layers of rock and earth, are able to uncover the hidden beauty below. Crystals like amethyst, garnet, and ruby grow in pockets within the crust, each one a perfect little world, shaped by the slow, deliberate flow of minerals. These pockets, often created by gas bubbles within the molten rock, form cavities that allow the crystals to take shape. The space within these cavities acts as a laboratory for the minerals to bond and grow, each process occurring at a microscopic level. Yet for all the quiet growth happening beneath, the process is never without change. The Earth's movements, the shifting of tectonic plates, the formation and collapse of mountains, can alter the course of crystal development. Earthquakes, volcanic eruptions, and even the settling of land can disrupt or disturb the delicate crystals in formation. But the deeper crystals continue to grow regardless, adapting to the changes, stretching further in search of stability. This ability to withstand such upheaval is a testament to the resilience of the Earth's forces and the patience of its hidden creations. Beneath the surface, there are no eyes to admire the crystals as they grow, yet they continue to shine in silence. These formations are the product of deep time, emerging not for an audience, but as natural byproducts of the planet's constant transformation. The minerals that bind together to form these crystals are the same materials that make up the Earth's surface, the same elements that make up the oceans, the air, and even life itself. There is a unity in this process, a quiet connection that underscores the Earth's ability to create beauty from the depths of its own structure. Even though they are born in darkness, many crystals are later revealed to the world through natural processes like erosion or volcanic eruptions. When a volcano erupts, it can bring these hidden gems to the surface, where they are slowly worn away by wind and water, eventually ending up as fragments in streams or clinging to the walls of caves. The Earth, in its unhurried way, reveals the wonders it has created, slowly unveiling crystals that have taken eons to form. These crystals, once brought to the surface, hold the secrets of their formation deep within their molecular structure. Every facet of their surface reflects the conditions under which they grew, shaped by heat, pressure, and time itself. It is these very qualities that make crystals so extraordinary. Their clarity, their shape, their color, all are records of the forces that shaped them. But more than that, crystals tell the story of a planet that has been in a constant state of flux, where new life, new materials, and new forms have been created and destroyed again and again. They remind us that beauty does not always come quickly. Sometimes, it takes millions of years of transformation to reveal something remarkable. These creations are silent witnesses to the Earth's most intimate processes, offering us a glimpse into a world of constant change and enduring resilience. As humans, we have come to treasure these crystalline forms, not just for their beauty but for the history they carry with them. When we hold a crystal in our hands, we are holding a piece of time itself, a snapshot of an Earth that has gone through immense changes to shape such a creation. And while we may see them as symbols of beauty or strength, they are, in their essence, the planet's quiet offerings, a gift from the Earth, born of its deepest forces and its slowest rhythms. In the same way that crystals grow in response to their environment, we too are shaped by the forces around us. The Earth's ability to transform minerals into crystals is a powerful reminder that even in the most extreme conditions, new beauty can emerge. It teaches us that growth does not always happen swiftly or easily. Sometimes it takes patience, endurance, and resilience. Crystals, in all their forms, remind us of the beauty in waiting, the strength in quiet growth, and the remarkable transformations that occur when conditions align perfectly over time. Deep beneath the crust, where no sunlight reaches, where no rain falls, where only the slow pulse of the earth remains, crystals continue to form. They grow in secret, unnoticed by human eyes, in conditions so extreme that only the most persistent minerals can endure. They take shape in the darkness, shaped by the slow pressure of the land above and the heat that rises from below. And yet, they are more than just geometric forms. Each crystal, formed under immense pressure and heat, is a record of Earth's deep history, a symbol of its enduring power to create beauty in places that remain hidden. As crystals form, they do so in the silence of the Earth's interior. They are not rushed. They grow slowly, each atom placing itself with precision and patience, building on the one before it. Each layer, each facet is a quiet act of creation. No hands shape these forms, no human eyes watch as they grow. Instead, the Earth's deep interior presses them into being, one small step at a time, each facet growing with purpose. The result is not a chaotic rush of material, but an ordered arrangement, a structure that, while seemingly random to our eyes, holds its own quiet order. This process of crystallization is not a simple one. It is a dance between heat, pressure, and time. The minerals involved, whether they are quartz, garnet, or even diamond, respond to the environment in which they form. The higher the temperature, the faster the growth, but also the more intense the pressure must be. At the same time, the minerals within the magma or sediment must also be just right. It is not enough to simply have heat and pressure. The right elements must be present in the right proportions for a crystal to form. This delicate balance is one of nature's quietest miracles, happening over thousands, even millions of years. It is not just the heat and pressure that shape crystals, but the subtle influence of the minerals themselves. As water seeps through cracks in the rock or magma cools and solidifies, minerals such as iron, magnesium, and silica begin to arrange themselves. In some cases, these minerals may be so pure that they form clear, colorless crystals, while in others, the minerals may combine in such a way that they produce vibrant colors. The deep purples of amethyst, the fiery reds of garnet, the rich greens of emerald, all of these colors are born of the mineral composition of the crystal. They are the result of years of slow crystallization, each color telling a different story of the forces at work beneath the surface. As crystals grow, they do not grow in isolation. They are part of a larger system, each one contributing to the slow and steady transformation of the rock around it. They often form in veins or pockets of rock, filling voids left by gases or other materials. These spaces allow the crystal to grow freely, without the pressure of the surrounding rock, but still within the constraints of the environment. Over time, as the crystal grows, the surrounding rock may also begin to change. The minerals in the rock may begin to interact with the crystal, altering its growth and composition. This process of interaction between the crystal and its environment is part of what makes each crystal unique. No two crystals are exactly alike, because no two environments are the same. The deeper into the earth one goes, the more complex the process of crystallization becomes. In the Earth's mantle, where temperatures can exceed 1,000 degrees Celsius, crystals of immense size and beauty form under extreme pressure. These crystals are not like the small, delicate ones found closer to the surface. They are large, often weighing hundreds of pounds or more. The pressure at these depths is so intense that only the most resilient minerals can endure. Some of the most famous crystals, such as diamonds, are formed in the mantle, where carbon atoms are subjected to immense pressure and heat. In this environment, the atoms bond in such a way that they form one of the hardest substances known to man. These diamonds, born deep within the earth, are carried to the surface by volcanic eruptions, where they are mined and prized for their beauty and rarity. But it is not just the pressure that shapes crystals. The Earth's movement, the shifting of tectonic plates, also plays a role in the formation of crystals. As these plates move, they bring with them materials from deep within the Earth. These materials, when exposed to the surface, can form new crystals. The collision of two plates, for example, can create an environment in which new minerals are formed, or old minerals are remobilized and crystallized again. This dynamic process of crystal formation is a testament to the constantly changing nature of our planet. Even when crystals are buried deep below the Earth's surface, their growth continues, hidden from view. The pressure from the overlying rock helps to push the crystals upward, but it also slows their growth. Over time, these crystals become part of the rock, locked away until erosion or volcanic activity brings them to the surface. It is through these natural processes that many of the crystals we find today were once brought to light. And yet, despite the forces that shape them, crystals remain delicate in their own way. Their structure, while incredibly strong, is also fragile. A single crack, a shift in pressure, can alter the crystal's shape forever. These fragile moments in the life of a crystal are what make them so precious. For while they are formed through immense forces, they are also shaped by moments of subtlety, of time, of patience. In the end, crystals are the products of a slow, steady process that spans vast stretches of time. They are shaped not by the whims of nature, but by its deep, quiet forces. Their beauty is not just in their form, but in the time they represent. They are not just objects to be admired. They are records of the Earth's slow transformations, testaments to the planet's ability to create beauty from pressure, time, and heat. Their quiet growth beneath the surface speaks to a planet that continues to shape itself, even when we are not watching. Beneath the soil, beyond the reach of light, lies a world teeming with life that remains hidden from our eyes. This is the deep biosphere, a realm so far removed from the surface that the organisms within it have learned to survive under conditions unimaginable to most living things. Without sunlight, without the familiar rhythms of day and night, these life forms have adapted to the extreme environments of the Earth's interior. Here, survival is not a race, but a slow and patient journey, marked by time and resilience. The creatures that inhabit the deep biosphere are not the vibrant, active beings we typically associate with life. Instead, they are microscopic, living in the tiny spaces between rocks and sediments, in the pores of deep ocean crusts, and even in the mantle itself. These are life forms that thrive in isolation, without the benefits of the sun's warmth or the nutrients provided by the surface world. They live off the energy stored in rocks and minerals, utilizing chemical processes to fuel their existence. It is a kind of life we often overlook, yet it is just as vital as the creatures that roam the surface. In the deep biosphere, life is powered by the Earth itself. Some organisms here rely on the decay of minerals in the crust, a slow and steady process that releases energy over millennia. Others harness the chemical bonds within the rocks, extracting what they need from the very material that makes up the planet's interior. These creatures feed not on the energy of the sun, but on the subtle flows of energy stored deep within the Earth's crust. The most famous of these life forms are the microbes, tiny organisms that exist in vast, undetected colonies, their populations stretching to billions, each one too small to see, yet collectively, They form the foundation of this underground ecosystem. What is remarkable about these life forms is not just how they survive, but how they thrive in the complete absence of sunlight. These organisms have evolved mechanisms to extract energy from inorganic materials, a process known as chemosynthesis. In chemosynthesis, the organisms use the energy from chemical reactions, often involving sulfur, methane, or hydrogen sulfide, to create the energy they need to survive. For some, this process is as simple as breathing in chemicals from the environment and using them to fuel their growth. For others, it involves intricate biochemical pathways that allow them to extract energy from the most unlikely of sources. The deep biosphere is not just a collection of single-celled organisms, though. Over time, larger and more complex life forms have developed in these dark, isolated spaces. In some places, tiny worms, shrimp, and even crustaceans have adapted to the extreme conditions of the deep biosphere, evolving features that allow them to survive in the harshest of environments. These creatures are often blind, their eyes useless in the eternal darkness. Instead, they rely on other senses, such as touch or vibration, to navigate their world. They have evolved to withstand extreme pressures, temperatures, and the lack of food, feeding on the bacteria and microbes that form the base of the food chain in these deep spaces. One of the most fascinating aspects of life in the deep biosphere is its resilience. These creatures have existed in these depths for millions of years, long before humans began to dig into the earth to study them. They have developed sophisticated strategies for survival, including the ability to endure in places where no other life could survive. Some organisms live in the deep biosphere's underground rivers, where they feed on the minerals dissolved in the water. Others live in the dark cracks and fissures of the ocean floor, where they consume the organic material carried down by water currents from the surface above. Life in the deep biosphere is not without its challenges, however. These organisms must contend with a lack of food, limited oxygen, and extreme pressures. Yet, despite these harsh conditions, life persists. The microbes continue to thrive in the spaces between rocks and sediments, where the environment is not only dark, but also devoid of the oxygen and other elements we associate with life on the surface. The deep biosphere is a realm of constant adaptation, where the slow rhythm of time has shaped the organisms to be more resilient than any other on Earth. Scientists are only beginning to understand the full extent of life in the deep biosphere. In recent years, researchers have discovered microbial communities living in the cracks of oceanic crust, deep beneath the seabed, feeding on gases and minerals released by volcanic activity. These discoveries have led to a deeper appreciation for the resilience of life and the potential for life to exist in the most extreme and isolated environments. The organisms found in these places are not just oddities. They represent the incredible adaptability of life, revealing the depths to which life can go to survive. Perhaps the most profound realization is that life in the deep biosphere exists without any external light, without the energy of the sun, and without the nutrients that flow from the surface. It is a life sustained by the earth itself, dependent on chemical processes that have been occurring for billions of years. These organisms are not just survivors. They are the living proof that life does not require sunlight, warmth, or oxygen to thrive. Instead, they show us that life is a force that can exist in the most unlikely places, surviving on what the earth provides in its deepest, most hidden corners. And so, beneath the earth's surface, where most of us never venture, a world of life exists that is so different from our own that we can scarcely comprehend it. In the dark, isolated spaces where light cannot reach, life continues to evolve, adapt, and endure. These slowest of creatures, these hidden organisms, show us that life is more than just what we see above the surface. It is a force that persists in the deepest, darkest places, where time flows slowly and patience is the key to survival. The Earth's surface is not a still, immovable entity. It is a living, breathing organism, constantly in motion. Beneath our feet, hidden in the deep places of the world, forces are at work that shape the land in ways we can scarcely imagine. It is here, deep within the Earth's crust, where the bones of continents are born. Mountains rise slowly over millions of years as the tectonic plates beneath the surface collide, fold, and buckle. These ancient processes create the towering peaks that pierce the sky. Yet their true origins lie far below, in the depths where unimaginable forces converge and reshape the planet's interior. The story of mountain formation begins with the movement of the Earth's tectonic plates, immense sections of the planet's crust that float upon the semi-fluid layer of the mantle beneath them. These plates are not static. They drift, collide, and interact with one another, slowly shaping the continents over geological time. When two plates meet, their collision initiates a chain of events that can lead to the birth of a mountain range. These tectonic movements, while imperceptible to the human eye, are constant and powerful, exerting forces that push up vast amounts of rock, creating the peaks and ridges that eventually form mountains. When two plates collide, the process known as convergence occurs. In this process, one plate is forced beneath the other in a violent push that results in the folding and faulting of the crust. As the plates converge, the immense pressure forces the rocks at the boundary to bend, fold, and sometimes even fracture. This intense compression causes the crust to thicken, forming the foundation of what will eventually become a mountain range. The higher the pressure and the longer the collision lasts, the more dramatic the result will be. Mountains such as the Himalayas, the Andes, and the Rockies are the products of such collisions, each one the result of the slow, patient work of tectonic forces. The movement of the plates is not a simple, linear process. It is marked by periodic bursts of activity followed by long periods of relative quiet. During these quiet times, the crust can settle and adjust to the new pressures, allowing the mountain range to grow slowly over time. But when the plates shift again, the pressure increases, and the rocks are pushed higher and higher into the sky. The Earth's crust continues to change and shift, and as it does, new mountains form, old ones erode, and the land continuously reshapes itself. The process of mountain building is not limited to the collision of two plates. Sometimes, mountains are formed when a plate is stretched apart, creating rift zones and fault lines. As the crust thins and weakens, magma from the mantle can rise to the surface, creating volcanic mountains. These mountains are born from the molten depths, erupting as the pressure of the Earth's interior forces the molten rock upward. The eruption of lava can build mountains over time, with each layer of volcanic material adding to the structure until it reaches towering heights. These types of mountains, such as the Hawaiian Islands, are built from the Earth's fire, their creation driven by the intense heat of the planet's core. Even as mountains rise, they are continually being shaped by forces on the surface. Erosion, the slow process of wind, water, and ice wearing away rock, works tirelessly to break down the mountains over time. What rises over time is worn down. Rivers carve deep valleys, glaciers scrape along the sides, and winds sweep away loose debris, slowly erasing the sharp edges of the mountains. Yet, even as the peaks are worn down, the process of their creation continues below, ensuring that new layers of rock are constantly pushed upward to replace what has been lost. In this way, the Earth's mountains are not just static features. They are dynamic, constantly in flux, shaped by both the forces beneath the surface and the elements above. In the heart of these mountains, The rocks themselves are records of the ancient Earth. Layers of sedimentary rock, folded and compressed under pressure, tell the story of the land's long history. These rocks may contain fossils, remnants of ancient life, and minerals that reveal the conditions of the Earth at the time of their formation. As mountains rise, they expose these ancient layers, offering a glimpse into the past, a history etched in stone that stretches back millions of years. The bones of continents are not just the rocks and minerals that make up the mountain, but also the fossils and other remains of life that have been preserved within them. At times, the creation of mountains can also lead to the formation of other geological features, such as earthquakes and volcanic eruptions. The immense pressure of tectonic movements can cause the ground to crack and shift, sending shockwaves through the surface. These seismic events are not merely random occurrences. They are part of the ongoing process of mountain building. As the plates move and shift, the land beneath our feet trembles, creating the seismic activity that we associate with earthquakes. These tremors are a reminder of the constant movement of the Earth, a reminder that the planet is never still. But the story of mountains is not just one of destruction. It is also a story of renewal. The rise of new mountains brings with it the creation of new habitats, new ecosystems, and new sources of life. As the mountains push upward, they alter the climate, create new patterns of weather, and influence the distribution of water and nutrients across the land. The formation of mountains can lead to the creation of valleys, lakes, and rivers, providing new spaces for life to thrive. Over time, these mountain ranges become home to diverse species of plants and animals, adapting to the harsh conditions of high altitudes, where oxygen is thin and temperatures are cold. In the grand scheme of time, the life of a mountain is but a brief moment. But in that time, the forces of nature work tirelessly to shape the land, creating peaks and valleys, ridges and plateaus. The bones of continents are forged in these slow, steady movements, rising inch by inch over millennia to form the towering structures we see today. Mountains are not just geological features. They are the product of deep, earth-shaping forces that continue to work beneath our feet, quietly and powerfully transforming the world around us. They remind us that the Earth is not a still, unchanging place, but a living, breathing entity, constantly shifting and evolving with time. The Earth's surface is not a quiet, static place. Beneath our feet, the planet is constantly in motion, shifting and changing in ways that we cannot always see or feel. Yet, even when the surface seems still, the Earth is remembering. It stores the tremors, the shifts, and the movements that have shaped it over millions of years. Every earthquake, every fault line, every seismic wave that ripples through the crust is not just a moment of disruption, but a memory that is etched deep within the Earth's fabric. This seismic memory is a record of the planet's past, a history of its geological evolution, and a testament to the ongoing processes that continue to shape the world we live in. When an earthquake occurs, the surface of the Earth momentarily shifts, releasing energy that has been stored beneath the surface. This sudden release of energy can cause the ground to shake, the buildings to sway, and the Earth itself to rearrange. But the effects of this release are not confined to the moment of the earthquake. The energy released travels deep into the Earth, radiating outward in waves that can travel great distances, carrying with them the imprint of the tremor. These seismic waves pass through the planet's crust, mantle, and core, creating ripples of energy that leave behind a trail of evidence. This is the seismic memory, the echoes of the Earth's movements, recorded in the layers of rock and soil that make up the planet's structure. Seismic waves move differently through different materials. Some waves travel quickly through dense rock, while others slow down as they pass through softer, more porous materials. As these waves travel, they leave behind a series of signatures that can be read by seismologists. By studying the way seismic waves travel through the Earth, scientists can learn about the structure of the planet's interior. They can identify the boundaries between layers of rock, the presence of faults and fractures, and even the movement of magma beneath the surface. In this way, the planet's seismic memory is not just a passive record. It is an active tool that allows us to peer into the depths of the Earth, uncovering the secrets of its internal workings. Every earthquake creates a unique seismic signature, a pattern of waves that reflects the specifics of the event, its location, its magnitude, and the nature of the materials involved. These signatures are stored in the Earth's crust, waiting to be discovered by those who know how to listen. In this way, the Earth's memory is written not in ink, but in waves, seismic waves that can be detected and analyzed by scientists. These waves carry with them the imprints of past events, allowing us to trace the history of earthquakes, volcanic eruptions, and other seismic events back through time. But the Earth's seismic memory is not limited to earthquakes. It is also recorded in the shifting of tectonic plates, the slow movement of continents, and the continuous process of plate subduction. Over millions of years, the movements of these plates shape the surface of the Earth, creating mountain ranges, ocean basins, and fault lines. These movements are not always dramatic or violent, but they are continuous, shaping the planet over eons. And as the plates move, they leave behind a trail of seismic evidence, a record of their slow, steady motion. In places where tectonic plates meet, such as the boundary between the Pacific and North American plates, the movement of the Earth is constant. These boundaries, known as fault lines, are where the most significant seismic activity occurs. Here, the Earth's crust is constantly being compressed, pulled, and stretched, creating the conditions for earthquakes and volcanic activity. The movement of the plates causes stress to build up along the fault lines, and when that stress is released, it results in the tremors we feel as earthquakes. These fault lines are like the scars of the Earth, marking the places where the planet has been shaped by the forces of plate tectonics. In addition to fault lines, the Earth's seismic memory is also stored in the folds and fractures that form in the Earth's crust. These folds, which occur when tectonic plates collide or shift, create the ridges and valleys that we see on the surface. These geological features are not just the result of immediate seismic events. They are the cumulative product of countless movements that have occurred over millions of years. The ridges and valleys are like the fingerprints of the Earth, unique to each region, and telling a story of the forces that have shaped the land over time. The seismic memory of the Earth is not just a passive record of past events. It is an ongoing process. The planet is in a constant state of flux, with tectonic plates shifting, magma rising and falling, and the Earth's crust adjusting to the forces at work beneath it. This dynamic, ever-changing nature of the planet ensures that the seismic memory is always being written, always being updated. Each earthquake, each tremor, each shift in the Earth's crust adds to the story of the planet's evolution. Even though seismic events are often brief and momentary, their impact can be lasting. The memory of a single earthquake can linger for years, as the ground slowly adjusts to the changes caused by the event. Sometimes, the effects of a seismic event are so profound that they reshape the landscape entirely. Rivers may change course, mountains may rise or fall, and entire cities may be destroyed. These moments of dramatic change are recorded not just in the history books, but in the very structure of the Earth itself. The planet carries the memory of these events, as though it were a living being, absorbing the energy and leaving behind a record that can be read by those who know how to listen. In the quiet moments between seismic events, the Earth continues to store these memories. It does so not in any visible way, but in the subtle shifts and changes that occur deep within the planet. The rock is constantly moving, always being compressed, stretched, or folded. The Earth is alive with the constant hum of seismic activity, even when it is not immediately apparent to us. And so, the seismic memory of the planet continues to grow, slowly but surely, adding layer upon layer of history to the record of the Earth's evolution. Through this seismic memory, we can understand the forces that have shaped our planet and continue to do so. The Earth does not forget. Every tremor, every shift, every movement is recorded in the rock and soil, a memory of the planet's past and a testament to the incredible forces that continue to shape the world around us. And as we continue to explore the depths of the Earth, we uncover more of these hidden records, piecing together the story of a planet that is constantly changing, constantly evolving, and always remembering. Beneath the vast, sunlit expanses of the oceans, there lies an entirely different world, unseen by the human eye. Far below the surface, beneath miles of oceanic crust and through the thick walls of stone, hidden seas exist, carrying ancient waters that have been sealed away for millions of years. These are the oceans beneath our feet, not formed by rain and wind, but by the slow and deliberate processes of Earth's inner workings. They lie dormant, tucked away in deep chambers, isolated from the surface world by layers of rock and sediment. The existence of these hidden oceans was once only a theory, a curiosity born from the understanding that beneath the Earth's crust, great reservoirs of water could potentially be locked away. But in recent decades, scientists have discovered proof of these secret seas, buried deep within the mantle, where water is trapped in mineral structures and confined by the intense pressure of the Earth's depths. These underground oceans are not like the oceans we know. They do not sparkle in the sun, and they are not home to the vast array of life we associate with surface waters. Instead, they exist in an almost frozen state, bound within minerals, yet still very much alive in their own way. As the Earth's tectonic plates shift, they create fissures and fractures in the crust, which can lead to the formation of subterranean reservoirs. Water, which has been trapped in minerals for eons, seeps into these pockets, accumulating in vast quantities. This process is not quick. It takes millions of years for these underground oceans to form, and they remain hidden from view, shielded by the rock that separates them from the surface world. But even in their deep slumber, they influence the world above, shaping landscapes and contributing to the planet's ongoing cycles. These hidden oceans are often found beneath the seafloor, where tectonic plates collide and subduction zones create the conditions necessary for water to be trapped in the mantle. When a tectonic plate is forced beneath another, water that has been absorbed into the rock is released, creating pockets of water that move deep within the Earth. Over time, this water can accumulate in vast underground reservoirs, forming oceans that remain undisturbed for millions of years. What is fascinating about these hidden oceans is the way they interact with the minerals around them. Water, under extreme pressure, can cause minerals to change their structure, creating new forms of rock and altering the chemistry of the Earth's interior. The minerals in the mantle are not just passive participants in this process. They actively engage with the water, pulling it into their crystalline structures, and storing it in a way that is fundamentally different from the way water exists on the surface. This interaction between water and minerals is a key part of the Earth's dynamic interior, shaping the planet in ways that are not immediately visible. One of the most intriguing aspects of these underground seas is the way they could influence the Earth's surface over time. As water is trapped in these reservoirs, it can be slowly released back into the surface oceans through volcanic activity, or it may seep through fractures in the crust, contributing to the formation of new bodies of water. The water in these hidden oceans is not stagnant. It moves, albeit at a very slow pace. As the Earth's geological processes continue to evolve, these oceans may one day surface, emerging into the light of the world above. The discovery of these hidden oceans also raises new questions about the origins of water on Earth. For centuries, scientists have debated how water arrived on our planet. Some theories suggest that water was delivered by comets or asteroids that collided with the Earth in its early history, while others point to the idea that water may have originated from within the Earth itself. The discovery of vast underground seas suggests that the Earth may have always had water, stored in hidden pockets beneath its surface. This raises the possibility that the water we see on the surface today is just a small fraction of what exists beneath our feet. The implications of these hidden oceans extend beyond our understanding of water. They also offer new insights into the geological history of our planet. The presence of such vast reservoirs of water deep within the Earth suggests that the planet's interior is far more complex and dynamic than we once thought. These underground oceans are not just isolated pockets of water. They are part of the larger geological system that governs the Earth's evolution. They are a reminder that even the most familiar aspects of our planet, like water, hold secrets that remain hidden in the depths. In recent years, scientists have developed new techniques to study these underground oceans, using seismic waves to map the flow of water beneath the Earth's surface. By observing the way seismic waves travel through the Earth's layers, researchers can identify areas where water may be stored deep within the mantle. These studies have provided valuable insights into the size and extent of these hidden oceans, revealing that they may be far larger than we ever imagined. The discovery of these underground seas has opened up new possibilities for understanding the planet's past, present, and future. As we continue to explore the depths of the Earth, we may one day uncover even more hidden oceans, buried deeper than we ever expected. These underground seas represent the unknown, the parts of our planet that are still mysterious and unexplored. They are reminders of how much we still have to learn about the world beneath our feet, and how much more there is to discover in the secret spaces of the Earth's interior. For now, these hidden oceans remain out of sight, quietly holding the secrets of the planet's past and future, waiting for us to uncover their mysteries. Within the folds of our brain lies a silent, invisible force, pulsing through the intricate network of neurons and synapses. It is the electricity of thought, the fundamental current that powers our every action, decision, and reflection. This electricity is not the kind we encounter in power lines or circuit boards, but a far more subtle form, one that flows within the very structure of our mind. It is a force that flows beneath our consciousness, a quiet current that carries information, communicates across distances, and enables us to experience the world around us in ways we can barely comprehend. At its core, thought is an electrical process. Neurons, the brain's basic units of communication, fire electrical impulses, transmitting signals to one another with astonishing speed. These impulses travel along delicate fibers, jumping from one neuron to the next across tiny gaps known as synapses. This process, while extraordinarily fast, happens in an intricate dance that is nearly impossible to visualize. It's a constant exchange of electrical energy, sending signals that direct our actions, govern our emotions, and form the foundation of all our cognitive abilities. When a thought occurs, it begins with the firing of an individual neuron. The electrical impulse that surges through this neuron causes it to release chemical signals, which travel across the synapse to the next neuron, creating a chain reaction of electrical activity. This process is the basis of communication in the brain, a system of electrical impulses that spread from neuron to neuron, forming networks of activity that we experience as thought. These networks are dynamic and adaptive, constantly shifting and evolving as we learn, experience, and adapt to the world. The speed and efficiency of this electrical transmission are nothing short of remarkable. In the time it takes for a single neuron to fire, an entire thought can be formed, processed, and acted upon. This rapid communication is facilitated by the myelin sheath, a fatty layer that surrounds the fibers of many neurons, allowing electrical impulses to travel at incredible speeds. Without this insulating layer, our thoughts would be sluggish, delayed, and disconnected. The speed at which we think, respond, and interact with the world is directly tied to the efficiency of this electrical network. And it is this efficiency that enables us to navigate our environment with remarkable agility. The electrical activity within the brain is not just a random occurrence, it follows patterns. These patterns are the building blocks of thought. Different types of electrical activity correspond to different mental states. For example, when we are awake and alert, the brain exhibits rapid, high-frequency electrical activity, known as beta waves. When we are relaxed or meditative, slower waves, such as alpha or theta waves, dominate. These electrical patterns correspond to our states of consciousness and reflect the underlying processes that govern our thoughts and perceptions. The electricity of thought is not limited to conscious thought alone. It extends to the deep recesses of the subconscious, where it influences our memories, emotions, and even our autonomic functions. In the subconscious, electrical activity governs not only our awareness but also the automatic processes of the body, our heartbeat, our breathing, the regulation of our internal systems. This electrical network stretches far beyond what we are conscious of, shaping our experiences and our reactions to the world in ways we may not even be aware of. Furthermore, this electrical activity in the brain is highly interconnected. Neurons are not isolated from one another. They form complex circuits that allow for the transfer of information across vast networks. These connections create a web of activity that spans across different regions of the brain, linking sensory information, memory, emotions, and cognition. The brain's ability to integrate these different functions is the result of these vast electrical networks, which allow for a fluid, cohesive experience of the world. The patterns of electrical activity that occur within these networks are what allow us to think, to feel, and to understand the world around us. What is most fascinating about the electricity of thought is its adaptability. The brain's electrical activity is not fixed. It changes in response to new experiences, learning, and environmental factors. This phenomenon, known as neuroplasticity, refers to the brain's ability to reorganize itself, forming new connections and pathways in response to changes. This plasticity is the reason why we can learn new skills, adapt to new environments, and even recover from injury. The brain's electrical network is constantly reshaping itself, making room for new thoughts, new behaviors, and new experiences. This adaptability also allows the brain to process an immense amount of information. Every moment, our brains are bombarded with a constant stream of sensory data, from sights and sounds to smells and touches. The electricity of thought helps to filter and process this information, allowing us to focus on what is important and ignore what is not. This is why we can carry on conversations, navigate through complex tasks, and make decisions, all while processing a tremendous amount of data in the background. It is the electrical activity in our brain that helps us prioritize, focus, and make sense of the world. The electricity that powers our thoughts is also linked to our emotional responses. The brain's electrical activity can be influenced by the chemicals that are released during emotional experiences. For instance, when we experience joy, Our brain releases dopamine, a neurotransmitter that enhances electrical activity in specific regions of the brain. This boost in electrical activity enhances our mood and reinforces behaviors that bring us happiness. Similarly, stress and fear trigger a different set of chemicals that alter the brain's electrical patterns, preparing the body for a fight or flight response. The role of electricity in the brain is not just theoretical, it has practical implications for our health and well-being. Brain disorders such as epilepsy, for example, are directly linked to abnormal electrical activity. In epilepsy, electrical impulses in the brain become too intense or erratic, leading to seizures. Understanding the electricity of thought and how it influences behavior and mental health is key to developing treatments for these disorders. Through medical advancements, we are able to manipulate electrical activity in the brain, offering hope for people suffering from conditions that affect the mind. In the end, the electricity of thought is more than just the impulses that pass through our neurons. It is the very essence of our mental and emotional lives. It connects us to the world around us, shapes our perceptions, and influences our decisions. It is a force that moves through us constantly, shaping our reality in ways we can hardly comprehend. The electricity of thought is the hidden energy that powers our minds, silently driving the process of understanding, feeling, and being. Water in all its forms flows through the earth like a quiet witness to time's passing. It is both a carrier of life and a recorder of history. Every droplet, every ripple, every wave that touches the shore carries with it the memory of the places it has been, the environments it has passed through, and the experiences it has absorbed. Water does not simply travel across the surface, it remembers. It carries the imprint of ancient climates, distant lands, and moments long gone, hidden within its molecules, waiting to be discovered by those who seek to listen. The idea that water has memory is not a new one. Ancient cultures, from the Egyptians to the Sumerians, recognized water as a sacred substance, capable of holding knowledge and power. But it is only in recent years, through scientific exploration, that we have begun to understand the depth of this idea. Water's memory is not the memory of a human being, nor is it a conscious recollection. It is an imprint, a record left behind by the environment it has interacted with. Through this memory, water becomes a timekeeper, a recorder of the Earth's past. When water moves through the landscape, it picks up elements from the environment around it. As it flows over rocks, through soils, and across the surface of the land, it dissolves minerals and absorbs particles from the air. It carries with it the chemical signature of the places it has passed through, storing these signatures in its structure. These signatures, though invisible to the naked eye, can be detected by scientists through careful analysis of the water's composition. They reveal the history of the water's journey, offering a glimpse into the Earth's past. One of the most profound aspects of water's memory is its ability to record the changes in the environment over time. Water, in its journey across the Earth, reacts to the climate, the seasons, and the geological shifts of the planet. It carries the imprint of these changes, like rings in a tree, telling the story of the world's evolution. When scientists analyze ice cores, for example, they can measure the concentration of gases such as carbon dioxide and methane, and from this, they can deduce the Earth's climate at different points in history. Water, trapped in these ice cores, holds the memory of the atmosphere's composition, of ancient climates, and of the changes that have shaped the planet. Water also holds the memory of human history. Rivers, lakes, and oceans have long been the sites of human activity, from the earliest civilizations to the modern world. As we have altered the landscape, so too has the water absorbed our influence. It carries the traces of the Industrial Revolution, the pollutants from factories, the chemicals from agriculture, and the waste of cities. Water is not just a witness to human history, it is a participant in it. It carries the fingerprints of human civilization, of our innovations and our mistakes, offering a record of our impact on the planet. But water's memory is not limited to the surface world. Deep beneath the earth, in the aquifers and the underground rivers, water carries the memory of the planet's internal processes. These deep waters, trapped in layers of rock, hold the record of the Earth's geological history. Water that has been locked away for millions of years holds the imprint of ancient geological events, such as volcanic eruptions, shifts in tectonic plates, and the rise and fall of ancient seas. When scientists drill deep into the Earth's crust and extract samples of ancient groundwater, they are uncovering a hidden record of the planet's past, written in the very water beneath our feet. Water's memory is not just a passive record of history, it is an active force in the shaping of life itself. As water moves through the landscape, it carries nutrients, dissolves minerals, and transports them to ecosystems that rely on it for sustenance. It shapes the growth of plants, the health of animals, and the cycles of life. In the oceans, water influences the climate, driving currents that regulate temperatures and weather patterns. It carries heat from the equator to the poles, balancing the Earth's temperature and supporting the diverse ecosystems that depend on it. The water cycle itself is a testament to the memory of water. As water evaporates from the oceans and lakes, it rises into the atmosphere where it forms clouds. These clouds carry the water across the land, where it falls as rain, snow, or hail. The water then flows into rivers and streams, where it once again returns to the oceans. This cycle is not just a process of movement, it is a process of memory, as the water carries with it the experiences of the places it has been. Each drop is part of an endless journey, moving through time and space, accumulating knowledge of the planet's changing landscape. The memory of water is also evident in the way it heals and restores. Water has long been associated with life-giving properties, with its ability to refresh and renew. The water we drink, the water that nourishes our bodies, carries with it the memory of the Earth's vitality. It is a reminder that, despite the wear and tear of time, the planet continues to regenerate itself, to renew itself through the cycles of water. It is a force of rejuvenation, a liquid record of the Earth's capacity to heal and restore. Water's memory is not confined to the past. It continues to evolve, to change, and to adapt as the Earth moves forward. It carries with it the imprint of the planet's ongoing evolution, of the shifting climates, the changing ecosystems, and the impact of human activity. As the Earth continues to transform, so too does water, constantly recording the changes and storing them for future generations to uncover. Water is not just a passive element. It is an active participant in the ongoing story of the planet, carrying the memories of the Earth's past and present, and shaping the future that lies ahead. Within the human body, there exists a remarkable phenomenon, one that often goes unnoticed but is as essential to life as the air we breathe. It is the light that lives in your bones, a soft, invisible glow that emanates from the very cells that form the framework of your body. This light, though imperceptible to the naked eye, plays a crucial role in the processes that sustain us, from the formation of new cells to the healing of fractures. It is the light of life, captured in the deepest recesses of our being, quietly working to maintain the balance of our existence. The light within our bones is not light in the way we commonly understand it. It is not a flash of brilliance or a visible radiance. Instead, it is a type of energy, radiation, that is emitted by the very atoms and molecules that make up our bone tissue. This radiation is a byproduct of the chemical reactions that occur within the cells of our bones as they carry out their various functions. The bones themselves are not static structures. They are living, breathing tissues that constantly grow, break down, and regenerate. This dynamic process releases a small amount of energy, a form of light that can be measured with the right instruments. This energy, which is invisible to our eyes, is a byproduct of the metabolic processes occurring within the bones. Our bones are not merely rigid structures. They are complex organs that perform a variety of functions. They store minerals like calcium and phosphorus, produce blood cells in the bone marrow, and provide support and structure for the body. These processes require energy, and it is this energy that generates the faint glow we associate with the light of the bones. It is not a light that illuminates the room, but rather a light that sustains life, hidden within the quiet operations of the body. The light within our bones is intimately tied to the process of bone remodeling, a continual cycle of bone resorption and formation. As we age, our bones undergo a delicate balance of breaking down and rebuilding. Specialized cells called osteoclasts remove old, damaged bone tissue, while osteoblasts create new, healthy bone. This process requires energy, which is derived from the nutrients we consume, as well as from the body's internal reserves. The energy released during this remodeling process is the source of the light that lives in our bones, a subtle manifestation of the body's ongoing efforts to maintain balance and health. This process of bone remodeling is essential for maintaining the strength and integrity of our bones. As we age, the rate at which we rebuild bone tissue slows down, leading to conditions like osteoporosis, where bones become brittle and more prone to fractures. The light within the bones serves as a reminder of the body's need for constant renewal and repair. It is a subtle indicator of the body's vitality, a signal that the bones are actively engaged in the ongoing task of supporting the body and maintaining its structure. But the light within our bones is not confined to the process of remodeling. It also plays a role in the healing of fractures and injuries. When a bone is broken, the body springs into action, sending signals to the bone cells to begin the repair process. This process involves the formation of new bone tissue, as well as the activation of specialized cells that help to bridge the gap between the broken ends of the bone. The energy released during this process, the light that glows softly within the bone, is a vital part of the healing process. It is a sign that the body is working to restore itself, to repair the damage, and to bring the bone back to its original strength. The light that lives in your bones also plays a role in regulating the body's mineral balance. Bone tissue acts as a reservoir for minerals like calcium and phosphorus, which are essential for various bodily functions, including nerve transmission and muscle contraction. When the body requires these minerals, the bones release them into the bloodstream, a process known as bone resorption. The energy released during this process is another form of the light that exists within the bones, a sign that the body is balancing its internal system to maintain homeostasis. In addition to its role in maintaining bone health, the light within our bones may also have a connection to the wider systems of energy within the body. Our bones, like every other part of our body, are connected to the electromagnetic fields that surround us. The energy released by the bones may be part of the body's larger network of energy, a network that connects all the cells and systems of the body in a delicate, harmonious balance. The light within the bones may be one small part of a much larger system, a system that helps to coordinate the body's functions and maintain its overall health. As we explore the concept of the light that lives in our bones, we begin to see how deeply interconnected our bodies are with the forces of energy and matter. The bones, once thought to be mere passive structures, are revealed to be active participants in the body's processes, radiating energy and light that sustain life. The light within the bones is a quiet reminder of the body's vitality, a symbol of the continuous cycle of life, growth, and renewal. It is a hidden force, subtle and often overlooked, but essential to the health and well-being of the body. This light is not something we can see with our eyes, but it is something we can feel, something we can sense through the way our bodies function. When we feel the strength in our bones, the resilience of our frame, we are feeling the light that emanates from within. It is a quiet energy, a reminder that even the most solid and unyielding structures in our bodies are full of life, full of movement, and full of energy. The light in your bones is not just a byproduct of cellular activity. It is a reflection of the body's ongoing efforts to support, heal, and sustain itself, to maintain the balance that is essential for life. In the quiet moments before dawn, when the world is still draped in the coolness of night, plants begin their silent dance with time. Their rhythm, though not obvious to the naked eye, is as precise as any ticking clock. The process is subtle but profound. Plants, in their own way, can count the hours. They are attuned to the cycles of light and dark, adjusting their behavior based on the passing of time in ways that support their survival. From the flowers that bloom at dawn to the leaves that close at dusk, plants maintain an inner sense of time, finely tuned to the natural world around them. This ability of plants to count time is not based on the ticking of a clock, but on an internal biological process known as the circadian rhythm. Like all living organisms, plants have evolved to adapt to the cycles of day and night. Their circadian rhythm is controlled by an internal molecular clock, a series of genes and proteins that regulate plant behavior on a roughly 24-hour cycle. This internal clock allows plants to predict the changes in light and darkness, and to adjust their growth, blooming, and energy production accordingly. It is a perfect example of how life on Earth is intimately connected to the passage of time. The circadian rhythm in plants is synchronized with the cycle of the sun, but it is not entirely dependent on external cues. While light and temperature are the primary environmental signals that reset the clock each day, plants also have an intrinsic timekeeping mechanism. Even in complete darkness, a plant's internal clock will continue to tick, allowing it to anticipate dawn and adjust its activities accordingly. In a sense, plants know when it is time to open their flowers, when to begin photosynthesis, and when to rest. They perform these tasks at the optimal times, ensuring they make the most of the resources available to them. This timekeeping ability is most apparent in the way plants respond to the sun. Many plants open their flowers during the day, using the sunlight to attract pollinators and to engage in the process of photosynthesis, which produces the energy they need to grow. As the sun sets and the light fades, the plants close their flowers and enter a period of rest. This cycle, though invisible to us, plays a vital role in the plant's life, helping it conserve energy, protect its reproductive organs, and prepare for the next day's activity. Some plants, like the sunflower, even track the sun's movement across the sky, ensuring they are always oriented to receive the maximum amount of light. This behavior is known as heliotropism, and it is another example of plants' remarkable ability to keep time. The timing of plant activities extends beyond opening and closing flowers. It also affects their internal processes, including the production of sugars, the uptake of nutrients, and the regulation of growth hormones. During the day, when sunlight is abundant, plants focus on producing sugars through photosynthesis, which is their primary source of energy. As night falls and the sun disappears, they shift their focus to other tasks, such as storing the sugars they have created and preparing for the next cycle. This precise coordination of activities guided by the plant's internal clock, allows it to function at its best and maximize its chances of survival. One of the most fascinating examples of plant timekeeping is the phenomenon of flowering. Many plants have evolved to bloom at specific times of day to attract particular pollinators. Some flowers open in the early morning, just as the sun rises, releasing their fragrance to lure insects such as bees and butterflies. Others bloom in the evening, when moths and other nocturnal creatures are more active. These plants are not merely reacting to external cues. They are anticipating the arrival of pollinators and timing their flowering to coincide with the best opportunity for fertilization. Plants also use their circadian rhythms to adjust to seasonal changes. As the days shorten in the fall and the nights grow longer, plants enter a period of dormancy. This behavior is part of a broader adaptation to the changing seasons, allowing plants to conserve energy during the colder months when sunlight is less abundant. The plant's internal clock helps it recognize these seasonal shifts, preparing it for the coming changes in light, temperature, and weather. In some plants, this change is marked by the shedding of leaves, while others slow their growth or stop flowering altogether. Beyond simply marking time, the circadian rhythms of plants have profound implications for their interactions with the environment. For example, research has shown that plants that maintain a healthy circadian rhythm are better able to withstand stress from environmental factors such as drought, extreme temperatures, and nutrient deficiencies. The internal clock helps them optimize their energy use, ensuring they can respond more effectively to challenges. Plants that are out of sync with their internal clock, due to factors such as artificial lighting or disruptions in their environment, tend to grow less efficiently and are more susceptible to disease and environmental stressors. In the natural world, the ability to keep time is essential for survival. For plants, it is a matter of life and death. By syncing their biological rhythms with the cycles of the sun and the changing seasons, plants ensure they are always in tune with the environment. Their internal clocks allow them to maximize their energy use, attract the right pollinators, and prepare for the changing demands of the environment. This synchronization is so finely tuned that even the smallest disruptions to the cycle can have a significant impact on their growth and development. As humans, we may not always notice the subtle rhythms of the natural world around us. But when we take a moment to look closely, we can see how deeply plants are connected to the passing of time. They open and close their flowers, grow and rest, bloom and fade, all in perfect harmony with the passage of the hours. Their timekeeping ability is a silent testament to the deep wisdom encoded in the living world, a reminder that every living thing is influenced by the forces of time, and that life, in all its forms, is an intricate dance with the passage of days and nights. In many ways, plants show us how to live in harmony with the natural rhythms of life. They remind us that time is not something to be rushed or ignored, but something to be respected and understood. Just as plants wait for the right moment to bloom, we too must learn to move with the flow of time, to recognize the right moment for action and the right time for rest. In their quiet, patient way, plants teach us the art of living in sync with the world around us, a lesson that goes beyond the mechanics of growth and reaches deep into the soul of life itself. Deep within the earth, in the region we call the core, lies a tremendous force that powers much of the planet's magnetic field. This force, though invisible, is a silent, constant presence that shapes everything from the behavior of compasses to the movement of the tectonic plates on the surface. It is the electricity of the Earth's core, a dynamic energy created by the molten metal and minerals churning and flowing beneath the Earth's crust. This energy is not simply a byproduct of the Earth's heat. It is an essential part of the planet's operation. Its heartbeat pulsing quietly but powerfully in the deepest reaches of the Earth. The core itself is divided into two layers. The outer core, which is liquid and composed mostly of iron and nickel, and the inner core, which is solid and composed mainly of iron. As the Earth cools, the inner core grows slowly, while the outer core remains molten, constantly in motion. These movements, coupled with the rotation of the planet, generate a powerful electrical current. This current, flowing through the liquid metal of the outer core, creates a magnetic field that envelops the entire Earth. The electricity of the core is not static. It is dynamic and constantly shifting, driven by the convective currents of the molten metal. This magnetic field is one of the Earth's most important features, as it acts as a shield, protecting the planet from the harmful effects of solar radiation. Without it, the Earth would be exposed to the full force of the sun's solar winds, which would strip away the atmosphere and make life as we know it impossible. The magnetic field, generated by the electricity of the Earth's core, plays a vital role in maintaining the conditions necessary for life on our planet. It is a reminder that beneath our feet, the Earth is a dynamic, living system, constantly working to protect and sustain life. The movement of the molten metals in the outer core also contributes to the planet's internal heat. As the metal flows, it creates friction and pressure, generating heat that radiates outward toward the surface. This heat drives the convection currents in the mantle, which in turn drive the movement of the tectonic plates. The electricity of the Earth's core, therefore, is not just a force that shapes the magnetic field. It is also a force that powers the planet's geological processes. The movement of the molten metal and the heat it generates are responsible for the continuous reshaping of the Earth's surface, from the creation of new mountains to the formation of oceanic trenches. But the electricity of the Earth's core is not just a mechanical force. It also has a profound effect on the planet's atmosphere. The magnetic field, generated by the electric currents in the core, interacts with the charged particles in the atmosphere, creating phenomena such as the auroras. These beautiful light displays, seen near the poles, are the result of charged particles from the sun colliding with the magnetic field and being funneled toward the poles. As these particles interact with the gases in the atmosphere, they produce bursts of light. The electricity of the Earth's core, through the magnetic field, gives rise to these spectacular displays, reminding us of the invisible forces at work in the natural world. The electricity of the core also plays a role in the planet's evolution. As the Earth formed, it was a molten ball of metal and gas. Over time, the heavier elements sank to the center, forming the core, while the lighter elements formed the mantle and crust. The Earth's magnetic field, generated by the convection currents in the outer core, is a remnant of this early process, an energy that continues to shape the planet's destiny. It is a force that has been at work since the planet's inception, guiding the development of the atmosphere, the oceans, and the surface features that we see today. The study of the Earth's core and the electricity that powers it is a relatively recent field of scientific inquiry. For centuries, the core was a mystery, hidden deep beneath the surface. It was not until the advent of modern technology that scientists were able to probe the Earth's interior and gain a better understanding of what lay beneath. Today, using seismology and other methods, researchers are able to study the behavior of the molten metal in the outer core and gain insights into the processes that drive the Earth's magnetic field. These studies have revealed that the core is not just a static mass of metal, but a dynamic, ever-changing system that is constantly at work, shaping the planet's magnetic environment and influencing the behavior of the surface. As we learn more about the electricity of the Earth's core, we gain a deeper appreciation for the complexity and interconnectedness of the planet. The forces at work within the core are not isolated. They are intimately connected to the forces that shape the surface and the atmosphere. The electricity of the core is the invisible force that links the deep interior to the outer reaches of the atmosphere, creating a system that supports life on Earth. It is a reminder that the Earth is not just a passive object floating in space, but a dynamic, living system that is constantly changing and evolving. The electricity of the Earth's core is a silent force, one that operates far beneath the surface and often goes unnoticed. But it is a force that shapes the world we live in, influencing everything from the magnetic field that protects us from solar radiation to the tectonic movements that create the continents. It is the heartbeat of the planet, pulsing steadily, invisibly, through the depths of the Earth, driving the forces that sustain life and shape the future of the planet.